Okay, let us begin today with the RH criteria based problem. So ROUTH HURWITZ criteria is what we are going to learn, and the question what you can see on the screen is what we are going to learn now. So here the given question is the open loop transfer function of unity negative feedback control system is given by g of s equals k divided by s into s square plus s plus 1 multiplied by s plus 4. Okay, so what you need to do is, the first part of the question is, using RH criteria, calculate the range of k values for the system to be stable and determine the value of k which causes sustained oscillations in the closed loop system, and what is the corresponding frequency of the sustained oscillation. So this is what the question is, and this is given in the VTO examination paper for 10 marks. Okay, so let us line by line let us solve this particular problem. So first step is, one second. So the first step is, you need to note down the given problem, which is g of s equals k divided by s into s square plus s plus 1. This is multiplied with s plus 4. Okay, so this is the question. Now what we need to do is, we need to generate, the first step is in RH criteria, the first step is we need to generate a characteristic equation which is 1 plus g of s into h of s equals 0. Okay, so this equation we need to generate. This is the first step which we have which we need to do in RH criteria. So here 1 plus, now g of s into h of s is nothing but this. Here h of s is equal to 1, because the given equation is a unity feedback control system. So unity feedback means the h of s, the feedback gain, will be equal to 1. So therefore 1 plus g of s into h of s equals 0. It means that 1 plus this given question, which is k divided by s into s square plus s plus 1 multiplied by s plus 4 equals 0. Okay, so now you take the LCM. What do we get here is s into s square plus s plus 1 into s plus 4 plus k, whole thing divided by s into s square plus s plus 1 into s plus 4 equals 0. Now if you see, this denominator will get multiplied with 0. So finally we can write the characteristic equation is s into s square plus s plus 1 multiplied by s plus 4 plus k equals 0. Now our job is to write the proper equation here. So let us do that. So here s into So I will multiply these two terms first. So it is s square into s is s cube plus s square plus s plus 4 s square plus 4s plus 4 plus k equals 0. So here s into s cube, so s into s cube is actually equal to s square, s to the power of 4, sorry. So this is s to the power of 4 plus, so you have one s square here and another s square is 5s square. So 5s square is multiplied with s becomes 5s cube plus, now you have s here, 1s here and 4s is here. So 4s plus s is 5s. So 5s into s will be 5s square plus, we have 4 here, 4 into s plus k equals 0. So this is your final, characteristic equation. Okay, so this is your characteristic equation. So now the next job is we need to construct the Routh array for this particular characteristic equation. So the next step is, the second step is construct Routh array. So to construct a Routh array, we need to draw two different lines here. One is horizontal line, a vertical line, and another one is horizontal line. We need to draw it. Now my job is to write the s power terms in the vertical side. So here s power terms is s power 4, s power 4, s power 3, s square and s power 1 and finally s power 0. So s power 0 is what? Now when I am writing the coefficients, now the thing is we need to take the coefficients of each s power term here. So the coefficient of s power 4 is 1, the coefficient of 5s cube is 5, the coefficient of 5s square is 5, the coefficient of 4s is 4, and the coefficient of, see, when there is nothing term of s here, it means that it is multiplied with s power 0. So we know that anything power 0 is 1. So the coefficient of s power 0 is a. Okay. So now we need to enter these coefficients in the Routh array. Okay. So these coefficients in the Routh array. So when we are entering here, s power 4 coefficient is 1. Okay. S power 4 coefficient is 1. The next coefficient for s power 4 line, every coefficient will jump 2 times. It means that when we take a particular row, if the coefficient s power 4 is beginning, then the next coefficient what we enter will be equal to s power 2 and the next coefficient will be equal to s power 0. Okay, so you are going to jump 2 times every time. So when it is even, you are jumping even 2 times jump you do, and if it is odd number you do 2 times odd number jump. So here s power 4 is 1. Now the next coefficient after 1 will be written for s square, which is 5. And similarly for s power 0 term will be written here, which is k. Now coming to the next one, here s power 3 is going to begin. So it means that it is an odd number. So you need to go to the next odd number. Okay. So here if it is starting from s power 3, the next odd number will be s power 1. Okay. So that is what. Next odd number means you should go towards lesser value, not towards greater value. So here s power 3 coefficient is actually 5. and the next odd number coefficient what we have here is 4, because 4 is multiplied with s power 1. So therefore it is 4. Now the next odd number we don't have anything here, because s power 0 is the last coefficient what we have. So we will write here 0. Now for any ROUTH HURWITZ criteria, when you take, the first two rows will be written based on the coefficients of the characteristic equation that you have. Now the consecutive rows of the ROUTH array should be calculated, should be found using RH criteria method. Now how to do that? Now think the coefficients of this is considered to be, the first coefficient is A11. So similarly, phi would be first row second column element, so A12. K would be first row third column element, so I will consider that as A13. Similarly, this phi I will consider this as second row first column element A21. This is second row second column element, so A22. This is second row third column element, so I'll say it is A23. Now our job is to find out third row first column element, third row second column element, third row third column element. So we need to find out this. Now according to the ROUTH array or ROUTH HURWITZ criteria, we have a formula for finding this row values where A31 equals, okay, we are going to multiply A21 into A12, minus A11 into A22, so we are going to multiply this 2 minus this 2, which is A11 into A22, and this whole thing will be divided by the value A21. Okay, so that is what the RH criteria formula that we use to find out the first element of the third row in the first column. Now coming to A32, which is equal to, now what we do is we multiply this with this. So you always multiply with the first column values only, and 1 is multiplied with 0 and you divide it by 5, means A21. So it is A21 into A13 minus A11 into A23, whole thing divided by A21. So this is your A32. Now coming to A33, we don't have any elements here. Okay, we don't have any elements here. So by default our A33 will be equal to 0, because we don't have any element to be multiplied. Okay, so coming to A31, let us calculate. 5 into 5 is 25. 25 minus 4, because 1 into 4 is 4. So 25 minus 4 divided by 5. So you get 21 by 5. So it is 5 4 is 20, 5 2 is 10. So you get 4.2. Coming to this value, A32 is 5 into k is 5k minus 0 divided by 5, it will give you k. Okay, so it is 5 into k minus 1 into 0 is 0 divided by 5. So it is 5k by 5, which will be equal to k. Okay, now coming to the next row now. Okay, so we found the third row. Now we need to find out the row of s power 1. Okay, we need to find out the row of s power 1. So again what we do is, what we did to the first two rows, we will now do it for these two rows. Same thing. Now what we will do is 4.2 into 4 minus 5 into k divided by 4.2. So it is, now what would be the entries of this row is, so this will be your A41, A42 and A43. So fourth row first column element, fourth row, second column element, fourth row, third column element. Now I will be finding out the values. So it is 4.2 into 4. So A41 is 4.2 into 4 minus 5k divided by 4.2. So what I will be getting is 16.8 minus 5k by 4.2. Minus 5k by 4.2. So here what is the value of this? 16.8 minus 4k, minus 5k minus 5k whole thing divided by 4.2. Now coming to A42, A42 will be 4.2 into 0 minus 5 into 0, because as both are 0, the numerator is 0, anything divided by 0 is 0. Okay. Now coming to the last row, which is A51, the last row element should be equal to the coefficient that you will be having at the end of your characteristic equation. So you will also get that only. See, you have this value which is 16.8 minus 5k by 4.2, and you multiply this with k, minus 4.2 into 0 is 0, and you divide it by this whole value. It means that what? 16.8 minus 5k divided by 4.2, this whole thing multiplied with k, minus 0, because 4.2 into 0 is 0, whole thing divided by this whole term, the first element, which is 16.8 minus 5k by 4.2. So anyway, this whole term minus 0 is, you get the same term. So 0, let me remove 0 here. So once I remove 0, you see that this term 16.8 minus 5k gets cancelled, and you are left out with only k. Therefore, I will be entering the value of k. Okay. Now this is the first column. What is the first column? This values whatever we have got is the first column, is what in ROUTH HURWITZ criteria, which is important. Okay. So we have 1, we have 5, we have 4.2, we have 16.8 minus 5k by 4.2, and we have k. Now our job is to find out what is the range of k for the system to be stable. So the first value of k would be this k. If you see, we know that according to the ROUTH HURWITZ criteria, let me tell me the definition of ROUTH HURWITZ criteria. So the ROUTH HURWITZ criteria says, for the stability condition, ROUTH HURWITZ criteria says, for stability, the first column of ROUTH array should not have any sign changes. Okay, so if there is no sign changes, it means that if there are no sign changes, if there are no sign changes, it means that there are no roots or poles. We normally consider this as poles because the characteristic equation what we find is actually, for example, if I take the closed loop system transfer function, D of s will be equal to G of s divided by 1 plus G of s into H of s. Now this 1 plus g of s into h of s is what the characteristic equation which we have considered, and this falls in the denominator. Now we know that for a closed loop control system, the transfer function for whatever we have written, the roots of the denominator is always poles, the roots of the numerator is always zeros. Therefore, if there are no sign changes in the first column of the Routh array, it means that there are no poles which lies on the right half of S plane, which lies on right half of S plane. Now if there are any sign changes, for example, if there are any sign changes, then the number of sign changes is equal to the number of poles lie in right half of S plane. So here we are not able to find the sign change because of the k term here, but we need to check the condition for the k range of k such that this both values of k will remain positive. This both value, because 1 is positive, it's a numerical value, 5 is positive, 4.2 is positive, but we need to find out the condition for these two conditions for these two elements to be positive. So that is only possible with the range of k value that we find out. Okay, so the first condition for the last element which we consider here, if k need to be positive, then the value of k should be greater than 0. So that is one range of k that we are able to say. K should be greater than 0. Now the second value of k would be k 16.8 minus 5k divided by 4.2 is the value what you have in this particular position of the element. So this should also be greater than 0. Means if that should be positive, if this overall value should be positive, then that should be greater than 0 only, right? So now if you multiply this 4.2 with 0, then you get the condition 16.8 minus 5k should be greater than 0. Now if I write this minus 5k towards right hand side, then I can easily say that 16.8 should be greater than 5k, or 5k should be less than 16.8. So therefore the final value of k would be k should be less than 16.8 divided by 5. So we get k should be less than 5 3s are 15. Okay, 6 minus 5 is 1.8. So 5 3s are 15 again, 5 6 are 30. So I think we get 3.36. So we get 3.36. So therefore the range of k should now be greater than 0 and less than 3.36. So this is the value of k that we are going to find out, range of k for the Routh table, or according to the Routh Hurwitz criteria. If the given system need to be stable, then we should see through that the range of k should be greater than 0 and less than 3.36. Okay, so this is the first part of the question which you can see. So what was the question asked earlier is, the question was, so this is the question which you can see, the given open loop control system whatever you have, using RH criteria calculate the range of k values for the system to be stable. So we found the range of k to be greater than 0 and less than 3.36, so that the system should be stable. Now determine the value of k which causes sustained oscillation in the closed loop system what is the corresponding frequency of sustained oscillation. Okay, so for the second part of the problem, it's quite simple. Again, you take the characteristic equation, which is s power 4 plus 5s cube plus 5s square so s power 4 plus 5s cube plus 5s square plus 5s square plus 4s plus k equals 0 plus k equals 0. Okay, now how to find out? Now you need to find out what is k. So which is k margin equals what? You need to find out the omega value also. So there are two ways in doing it. Okay, first way I will tell you how to do it, and then we will look into the second way. So the first way is you need to go back and look into the Routh array. Okay, this is the Routh array whatever we have. This is the Routh array whatever we have. Now where exactly the value of k, when you substitute, the element in the first column becomes 0. Now for example, if you put 3.36 in this 16.8 minus 5k by 4.0, if you put k to be equal to 3.36, then 5 into 3.36 would be equal to 16.8. So 16.8 minus 16.8 would be 0. So this element would become 0. Which one? This element would become 0. Now all the element of the row is all zeros you get. So this is also 0. So all zeros you get. So therefore the row behind, before this row will be considered to write the auxiliary equation. So here the step is you need to write the auxiliary equation to find out the value of omega. My job is to write the auxiliary equation to find out the value of omega. Now we easily found that when the term becomes 0, when k value is 3.36, therefore that is the k margin. So that is the k margin, which is equal to 3.36. So we got the value of k margin, which is 3.36. So because of 3.36, this term was becoming 0. Okay. Now my job is to write the auxiliary equation, and auxiliary equation it will be written in terms of 4.2 and k. Now what is that 4.2? 4.2 is the row corresponding to s power 2. So therefore it is 4.2 s square, okay, plus k into s power 0 will remain as k equals 0. So this is the auxiliary equation. Now you need to substitute what is k. So the k value is 3.36, the margin value. So the k value is 3.36. So if I substitute that here, I will be getting 4.2 s square plus 3.36 equals 0. Therefore s square 4.2 s square will be equal to minus 3.36. Therefore s square is equal to minus 3.36 divided by 4.2. So if I use the calculator and see what is 3.36 divided by 4.2, I will be getting 0.8. So s square equals minus 0.8. So s will be equal to one second. S will be equal to plus or minus j into because s will be equal to square root of s will be equal to plus or minus square root of minus 0.8, and this can be written as plus or minus square root of minus 1 into square root of 0.8. Now we know that square root of minus 1 is j, so that is what I have written here, plus or minus j into. So if I say what is square root of 0.8, so if I say what is square root of 0.8, I will be getting 0.894, 0.894, and therefore this is the value of s in terms of plus or minus j into 0.894. In this would be the omega value. So omega is equal to 0.894 radians per second. So this is your value of omega. So this is the k margin and omega value for the given problem. So this is how we found the frequency of the sustained oscillation, and frequency of sustained oscillation means nothing but omega. The frequency of sustained oscillation is nothing but omega. Frequency of sustained oscillation. And to obtain this frequency of sustained oscillation, the k value is 3.36. So this is what they have asked in the question. If you go back and look into the question, determine the value of k. So I found which is 3.36, which causes sustained oscillation. Okay, what is the corresponding frequency of sustained oscillation, which is omega. Okay, now this is one method where we found k and omega. I think there is one more method which I can tell you, where you replace, let me check whether we will get that, you replace s to be equal to j omega in this equation. Okay, replace s to be equal to j omega. So what will I get here is j omega to the power of 4 plus 5 into j omega to the power of 5, 3, 5 into j omega to the power of 3. So this is the second method which I am telling you, to replace s with j omega and write the characteristic equation in terms of not s now, in terms of j omega, plus 5 into j omega square plus 4j omega plus k, plus 4j omega plus k equals 0. Now we know that in mathematics j equals square root of minus 1, so j square equals minus 1. So if I say j to the power of 3, it is equal to minus 1 into j square is minus 1 into j, so it is minus j. Similarly, if I say j to the power of 4, it is equal to j square into j square. So we know that one j square is minus 1, the another j square is minus 1, minus 1 into minus 1 is plus 1. So therefore, if I put 1 here, so I will be getting omega to the power of 4, because j to the power of 4 into omega to the power of 4, j to the power of 4 is 1 and omega to the power of 4 into 1 is omega to the power of 4. So j cube is what? Minus j. So I can say it is minus 5j and omega cube. So j cube is minus j, that is why it is multiplied with 5 is multiplied with minus j, and then you have omega cube. Now j square is minus 1, so it is minus 5 omega square plus 4j omega plus k equals 0. Now we are going to separate the real part and the imaginary part. The real part would be omega to the power of 4 minus 5 omega square plus k is the real part, plus j into 4 omega minus 5 omega cube equals 0. Okay, plus j into, now this is what I wrote, the real term is without j. Now omega to the power of 4 is without j, minus omega square is without j, and k is without j. So therefore this three terms is without j. Omega 4 minus 5 omega square plus k. Now these are the two terms which are with j, minus 5j omega cube plus 4j omega. So if I take j common plus j common, this will become 4 omega and this will become minus 5 omega cube. Now you equate real part and imaginary part to 0. So if I equate 4 omega minus 5 omega cube, 4 omega minus 5 omega cube equals 0, then I can say it is 5 omega cube equals 4 omega. So 5 omega square equals 4. Omega square equals 5 4 is 20. 4 by 5. Sorry, 4 divided by 5 is 0.8. 5 8 is 40, right? So 4 divided by 5 is 0.8. So omega equals square root of 0.8 plus or minus square root of 0.8. So anyway, we don't take minus value for frequency, so it is plus 0 root of 0.8, and we saw here root of 0.8 was 0.894. So omega equals 0.894. So this is the value of omega. So same value of omega we got here also. Okay. Similarly, equating the real part to 0, I will be getting omega to the power of 4 minus 5 omega square plus k equals 0. So I am equating the real part. So this was the imaginary part equating to 0. Imaginary part equating to 0. Now I am equating the real part to 0. Real part to 0. So this is your imaginary in the equation. This is your real in the equation, and this is your imaginary term in the equation. So I am equating both to 0 to find out omega and k. So yeah, now if I equate this real part to 0, then what will I get here is omega to the power of, so k would be equal to, I'll take minus 5 omega square to the right hand side, this becomes plus 5 omega square, and omega to the power of right hand side, this becomes minus omega to the power of 4. So I'll say it is 5 into 0.894 whole square minus 0.894 whole to the power of 4. Anyway, this is 89. So now if I do this, 5 into, so if I do this 5 into 0.894 will give you 3.996 minus, so if I go with 0.894 to the power of 4, so I'll be getting 0.894. So I'll be getting 0.638. So if I subtract these two, I'll be getting 3.996 minus 0.638. I'll be getting 3.358. Or I can say k value equals 3.36. See, in the second method also, we got omega value and k value, whatever we got in the first method. Okay, so this is how in RH criteria we try to solve the problem to find out the range of the value of k, and also to find out the value of k to find out the sustained oscillation condition, and also the frequency for the sustained oscillation, which is omega value, by considering the auxiliary equation. And where exactly we consider auxiliary equation is, we need to go back to the Routh array that we have constructed, and if I put the value of k margin here, this particular element becomes 0. So all the elements of this particular row will become 0. Therefore, we are going to consider the previous row elements to construct the auxiliary equation. Once we construct the auxiliary equation, we will be trying to find out what is the omega value, and whatever the k value that we have substituted to become that element as 0. that would be the value of k margin, and that would be the value of k that we consider to substitute so that we can get the value of omega at the end. So this was the first method. Second method is, instead of auxiliary equation or instead of RH criteria Routh array, you can also find out the value of omega and k by substituting S equals j omega in the characteristic equation. I think this second method would be most appropriate for you to use in root locus construction. Okay, because in root locus construction, we need to find out this omega and k value. So if you construct RH array, Routh array, and then find out the auxiliary equation and then find omega and k, so that would take more time. So to avoid that, what we can best do is construct the characteristic equation, and for that characteristic equation replace S with j omega. Therefore, once you do that, you will be getting two parts. One will be the real part and another will be the imaginary part. Now, equating both imaginary and real part to equal to 0, you will be getting both omega and k values. Okay, so this is what the RH criteria discussion what we needed to